This video is very special to me. During COVID lockdown, when I started thinking how to utilize the time effectively, CNC Learning YouTube channel was born. First video was on CNC Basics. When I look back, I see a lot of opportunities for improvement. At a time when the channel crossed more than 5,000 subscribers, I consider revising this content. I hope you would love this. Please don't hesitate to share this content to your near and dear. Happy learning.
We will start with what is CNC. CNC is an acronym. It means it's a short form for computerized numerical control. Any machine tool connected with a CNC controller is nothing but a computer, and having a spindle and servo drives for the access for program controlled movements. Such a machine is called a CNC machine. We look at the movements of a CNC turning center. So you can see this is chuck, this is turret, and now the tool is changed, slide movement, this is tail stalk. This is the CNC controller where we store the CNC program and the operator can control the basic operation of the machine using this controller. And based on the program commands, the controller will issue commands to control circuit in terms of voltage signals, and that will go to amplifier and will get amplified, and those signals will be fed to the rotary encoder, which is connected to a servo motor. So the servo motor will be rotating, and the rotational movement of servo motor will get translated to linear movement of the slide through the bore screw. We'll see how this motion happens.
If this nut is moved, it will also have a linear displacement. So you can see when the nut is rotated, it is also getting moved. It's a ball nut. If this
So once based on the commands, the signal will be translated to a linear movement, and this CNC machine is a closed loop system. It means whatever command is issued from CNC controller through the control circuit and amplifier, whether the movement of the slide is exactly meeting as per that. That work is done by this rotary encoder. So the rotary encoder will check exactly the movement, and any difference found will be fed back to the system, and accordingly the compensation of the movement will be given.
if this
We'll see how CNC machines are classified. It can be classified in two different ways. One is based on the process, another one is based on the number of axes. Based on process, it is classified as CNC turning, milling, turn mill or mill turn, and wire EDM. Based on number of axes, two axes, that is the basic turning center, and that is the minimum number of axes, two axes, X and Z, and then further it goes up to say 9 axes. So a VMC with 3 axes, HMC with 4 axes, 5 axes, goes on like that. In general, if you see, any kind of machining can be done by 5 axes. Other axes are supporting axes like subspindle, second turret, etc. That will be applicable in a turn mill center. Now we will see how the axis is named in a milling center. This is the operator side and this is the machine table. So the axis which is going parallel to the spindle is called Z axis, and the axis which is going horizontal to the operator is called X axis, and the other perpendicular axis is called Y axis. Now some machines the slide will be moving, and in some machine the head will be moving or the spindle will be moving. But this movement, now the arrow shows X axis plus direction, the opposite will be X minus. Now the movements, always the programmer has to consider the relative movement. He need not worry about the actual movement happening on the machine, whether it is a slide or the milling spindle. He should always look at the relative movement in Cartesian coordinate system. So the same is depicted in a conventional machining center, milling machine. And it is also explained by right hand rule, which says if you keep your 3 fingers, thumb, forefinger and middle finger, in a way that the thumb point to the x-axis and the forefinger point to the y-axis, then the middle finger will point to the z-axis. So in a normal VMC, you need to hold the hand like this, and for a HMC, it will be like this. Now, how the axis is named in turning, we'll have a look at. The axis which is going through the spindle is always Z axis, and the axis which is perpendicular to it, it is X axis or diameter axis. Here you can see it's a horizontal bed, no slant bed. Spindle axis is Z axis and the perpendicular axis is X axis. The direction which is going towards right is Z plus, and the direction which is going inside the spindle is Z minus, and the direction which is going away from spindle is X plus, towards the center is X minus. And a VMC, the directions which we have already seen, so this is X axis, which is the horizontal axis of the operator, and spindle axis is Z axis, and the perpendicular axis is Y axis. Now, what are the main parts of a CNC machine? A CNC machine will have a main spindle, and in this picture what you are seeing is that of a turn mill center. So you can see a chuck with jaws, a turret, and a tailstock. And here also you can see there are two axes for X and Y and one for Z axis. On a milling center or machining center, there will be a main spindle which is a milling spindle, and there will be a work table, and there can be a rotary table wherever it is applicable. So in this case we are seeing a rotary table with fixture and then tailstock support. And there will be a tool magazine where all the tools will be loaded, and there will be an ATC, automatic tool changer, for loading the tool to and from the tool magazine. A tool magazine will look like this: several holders loaded with tools. So here also you can see one tool magazine and an ATC. You can see how the holder is positioned, and how the ATC is keeping the holder in position, mounting another tool back, loading to the magazine. A 4-axis machine. So we have already seen in a VMC there will be a rotary table wherever it is applicable. So if your machine is equipped with a rotary table, it can be called as a 4-axis machine. So 3 linear axis and 1 rotary axis. So in this case you are seeing an A axis because this axis rotates about X axis. So the rotary axis are counted like that. The axis which is rotated about X axis is called A axis. About Y axis it is called B axis, and about Z axis called C axis. You can see a small video of a 4-axis machine. You can see this rotary axis is about X axis, so it is called A axis. And this is an HMC, horizontal machining center. So you can see the axis of the spindle is horizontal, and we have already seen the spindle axis will always be Z axis, and the axis horizontal to the operator will be X axis, and the third axis will be Y axis. And here in this case the rotary axis is about Y axis, so it is called B axis. turning center. See, this is the rotary. Now we will look at the different configurations for turn mill machines. A machine with 3 axes, that is, we already seen a turning center will have 2 axes, X and Z. In addition to that, if there is a control movement for the spindle, then it is called C axis. And turn mill center with 4 axes, along with X, Z and C, there will be one more Y axis, and then 8 axes and 9 axes. There will be 2 spindle and 2 turrets. And for 9 axes, along with the 2 turret and 2 spindle, there will be one tilting spindle. So the tilting rotary will be the 9th axis. So this is a turn mill with C axis. So there is a control movement for the spindle. And this is a mill turn center. We'll see what is the difference between a turn mill center and mill turn center. Turn mill center is a machine where you can do more of turning and light milling. Whereas in mill turn center, you can do both the turning and milling, and even heavy milling can be done. So if you look at this machine, there will be so many axes, 3 axes on the milling head. So Z axis, X axis and Y axis, 3 linear axes and 1 rotary on the head, and then there will be 2 axes on the lower turret, C axis on the main spindle and C axis on the sub spindle. That means on this machine there will be another spindle on the right hand side, and the sub spindle will come to the main spindle to do a job transfer. So whatever part is there in the main spindle, once the main spindle operation is completed, sub spindle will come and pick that part, or vice versa. So that movement is another one. So everything put together, you will have 9 axes on such a machine. Now we will look at a video of Mosaic Integrex mill turn.
Now I am in Intex 2023, and the machine which is in my background is a very beautiful machine. It is Intex, and it's a 5-axis machine, multitasking machine, mill-turn center. You can see the head is tilting. Now we can make a simultaneous 5-axis component. You can see the component in the so the head is already tilted and the machining is going on. It should bring down another. This is simultaneous operation. Now this operation is simultaneous operation.
Now we will look at different configurations of 5-axis machine. Based on the two rotary axes, it is configured as table table, head table, and head header. First, we will look at a machine with table table configuration. So you can see in the picture the rotary axis. Both the rotary axes are configured on table. That is why it is called table table configuration. So in this case, one axis is on x-axis, so it can be called as a-axis. Another one is on about z-axis, so it is called c-axis.
Five-axis machine. So you can see the simultaneous movement of axis. Now the tool is getting changed. It's a finishing tool. It's a simultaneous 5-axis motion. All 3 linear axes and 2 rotary axes, they are working together.
Now we will look at a machine with head table configuration. That means one rotary will be on head and another will be on table. So what is on table? It is rotating about the z-axis, so that can be called a c-axis. And the axis, rotary axis, which is on the head, that is getting rotated about y-axis, so it can be called as b-axis.
This machine is having a head and table configuration. There is one rotary on head and the other rotary is on table.
Yes.
Yeah.
Now we will look at the third type, which is head-head configuration. That means both the rotary will be configured on the head. So if you look at this picture, there will be one rotary which is rotating about the z-axis, that can be called as a c-axis, and the other one is configured rotating about y-axis, it can be called as a b-axis.